Skeletal muscles are made up of several layers. The muscle belly is made up of many fascicles. Fascicles are bundles of muscle fibers or cells. Within each muscle cell there are many myofibrils, which are bundles of myofilaments, including actin, myosin, troponin, and tropomyosin.
Taking a closer look at a myofibro, we see that the Z-line is the anchoring point for the actin or thin myofilaments. The myosin or thick filaments lie between the actin. The sarcoplasmic reticulum branches throughout the fiber and holds the calcium ions that will be necessary when contraction occurs. The I band appears light under a microscope because it contains thin actin filaments. The A band appears dark because it consists of the thick myosin filaments. The H zone is the area where there is only thick filaments and no overlap with the thin filaments. The region from one Z-line to the next is called a sarcomere and is the smallest contractile unit of a muscle.
The receiving end of a neuron is made up of dendritic branches. The received message then travels down the axon towards the synapse at the axon terminal. The synapse is the space between the neuron and the motor end plate. At the neuromuscular junction, an actin potential is sent to the axon terminal, which opens the calcium ion channels. As calcium enters the presynaptic terminal, the vesicles containing acetylcholine are released. After diffusing across the synaptic cleft, the acetylcholine binds to the receptor, which opens the sodium-potassium channels. Sodium enters the cell and potassium exits. The flow of the ions depolarizes the sarcolemma surrounding the muscle cell. The action potential is sent along the sarcolemma, down the T-tubules, and throughout the sarcoplasmic reticulum. This causes the release of calcium ions at the end of the sarcoplasmic reticulum. The calcium then binds to the troponin myofilament. This causes the troponin to change shape, which rotates the tropomyosin myofilament. This reveals the binding sites for the myosin heads. Since myosin and actin have natural affinity towards each other, the myosin heads form cross bridges as they bind to the actin. A power stroke occurs when the myosin heads contract and pull the actin. ATP is needed for the myosin heads to release from the binding sites on the actin. When ATP binds to the myosin, the heads return to their relaxed position to prepare for the next power stroke to pull the actin further. A relaxed sarcomere has a little overlap between the actin and the myosin filaments. In a contracted sarcomere, the H zone disappears and the I band becomes very small as the distance between the Z lines decreases.